Hi Pre-Algebra students, this is Chapter 6.6, which is all about scale drawings. We're going to use what we've learned about solving proportions to create scale drawings. This is pretty fun. Let's get started. This map is an example of a scale drawing. It shows a portion of a large city built over 2,000 years ago, the ruins of which still exist in central Mexico. A scale drawing is a two-dimensional drawing that's similar to the object it represents. A scale model is a three-dimensional model that's similar to the object it represents. The scale of a scale drawing or scale model gives the relationship between the drawing or the model's dimensions and the actual dimensions of the object that is represented. For example, in this map shown here, the scale 1 centimeter to 200 meters means that 1 centimeter in the scale drawing represents an actual distance of 200 meters at the site. So on the map, the center of the pyramid of the sun, right here, is 4 centimeters from the center of the pyramid of the moon. That may not be true on your screen, but it is true on the paper map, so go with me here. The ratio of the map distance between the two pyramids to the actual distance, x, is equal to the scale of the map. So let's write and solve a proportion using that relationship to find the actual distance from the center of the pyramid of the sun to the center of the pyramid of the moon were we to visit the site. Okay, so let's begin with the scales, which is 1 centimeter to 200 meters. And let's set that equal to the distance on the map, which we said was 4 centimeters, over x, the actual distance. Now we use what we know about cross products to get x centimeters being equal to 800 meters. So were we to visit the actual site, we'd have to walk 800 meters to go from the center of the pyramid of the sun to the center of the pyramid of the moon. Using this map, complete this checkpoint problem. On the map, the pyramid of the sun has a length and a width of 1.1 centimeters. What is the actual dimension of the pyramid of the sun? Press pause while you work, and next we'll find the scale of a drawing from known measurements. Now let's find the scale of a drawing. Every few years, the Grand Place in Brussels, Belgium, is decorated with a large floral carpet made of begonias. Before making the carpet, designers make detailed scale drawings. Suppose the floral carpet is to be 40 meters wide. A designer creates a scale drawing of the carpet that is 20 centimeters wide. Find the drawing scale. So we're going to start by writing a ratio using the corresponding side lengths of the scale drawing and the actual carpet. Then we're going to simplify so that the numerator is 1. So the width of the scale drawing is 20 centimeters. The width of the actual carpet is 40 meters. Now we simplify. 1 centimeter to 2 meters. So the drawing scale will be written like this, 1 centimeter to 2 meters. Done. Do note here that our units are different, so we need to include them on the scale. However, if we wanted to write the scale without the units, we would simply need to convert our 2 digits so that they were in the same units. So we could write this 1 to 200, so that we did not have to include the units if you wish. That way we would have 1 centimeter to 200 centimeters, and we have our scale without units. Let's wrap up Chapter 6.6 by finding a dimension on a scale model. So far we've been working only with scale drawings. You'll see that working with a scale model uses exactly the same technique. A model of a space shuttle has a scale of 1 to 52. The space shuttle has a wingspan of 78 feet. Find the model's wingspan. So we begin by writing a proportion using the scale. The first part of our proportion is the scale itself, 1 to 52. That's going to be equal to the dimension of the model, our unknown quantity, over the 78 feet, the known width of the space shuttle. Now we use cross products to solve. 52m equals 78 feet. So the wingspan of the model is 1.5 feet. Now solve this on your own. The length of the space shuttle is 122 feet. Find the length of the scale model to the nearest tenth of a foot. All right, when I see you tomorrow, we'll do some more work with scale drawings and scale models. This is a fun application of all of the work we've been doing in Chapter 6. See you then.